Okay, today we're going to do integration by partial fractions. So let's take a look at the first example. We have x squared plus 4x plus 1 divided by x minus 1, x plus 1, x plus 3 dx. First thing is we're going to write this as the integral of a divided by x minus 1 plus b divided by x plus 1 plus c divided by x plus 3, and our job is to find a, b, and c. To find a, b, and c, we're gonna write x squared plus 4x plus 1 equals to a times x plus 1 times x plus 3 plus b times x minus 1 times x plus 3 plus c times x minus 1 times x plus 1. The idea is to put the fraction on the left equals to the partial fractions on the right, and then clear fractions. Okay, so multiply by the common denominator, and that's what you get. Alright, so to find a, b, and c, we're going to go ahead and let x equals to 1. X equals to 1 is going to give us, on this side, 1 plus 4 plus 1, which is 6, and on the other side is going to give us 1 plus 1, which is 2, and then 1 plus 3 is 4. So it looks like it gives us a equals to yeah, let's see. A, because is 1 plus 1, which is 2 times 4, which is 8, and that gives you a equals to 6 over 8, or 3/4. Then you let x equals to minus 1, and you get, this time I'm going to go ahead and write it down, because otherwise I would make a mess. Of minus 1 squared plus 4 times minus 1 plus 1 on the left hand side, and on the right hand side we're just gonna have let's see, b times minus 2 times 2, and this side will give us minus 4 plus 2, so minus 4 plus 2 will give you minus 2, and then minus 4b, and then this gives us b equals to 1/2. And then finally we plug in x equals to -3, and then that gives us minus 3 squared plus 4 times minus 3 plus 1 on this side, and on the other side we just get c times minus 3 minus 1 is minus 4, and then minus 3 plus 1, it's -2, and that will give you minus 2 equals to 8c. So c equals to minus 1/4. Alright, so by finding that, we have integral of a was 3/4, so 3/4, 1 over x minus 1. B was 1/2, so 1/2, 1 over x plus 1. And C was minus 1/4? Yeah, minus 1/4, 1 over x plus 3. Like this. And then we just integrate. So 3/4 times the natural log of x minus 1 in absolute value plus 1/2 times the natural log of x plus 1 in absolute value minus 1/4 times the natural log of x plus 3 in absolute value plus c. Okay, now we're gonna do one where we have sort of like repeated values. So repeated linear factors. Something like this integral, 6x plus 7 divided by x plus 2 squared. This time we have 6x plus 7 divided by x. So this time this will be equal to the integral of a divided by x plus 2 plus b divided by x plus 2 squared, because x plus 2 is repeated, like that. And we need to find a and b. So 6x plus 7 divided by x plus 2 squared, like this, equals a x plus 2 plus b x plus 2 squared, and then we clear fractions, so we get 6x plus 7 on this side, and on this side we get a times x plus 2 plus b. So we're going to choose x equals to minus 2, and then we get minus 6 times minus 2 plus 7 on this side. And then on the other side we're just going to get b, so this will give you b equals to minus 5. And setting x equals something else other than minus 2, maybe x equals to 0 will give us 7 on this side and 2a plus b, but since b is already minus 5, we get 7 equals 2 minus 5, so adding 5 to both sides, we get 12 equals 2a, so a equals 6, and therefore we get the integral of a, which was 6 divided by x plus 2, minus 5 divided by x plus 2 squared, dx like this, and this will be equals to 6 times the natural log of x plus 2 plus 5 times x plus 2 raised to the minus 1 plus c. This is when you integrate both parts. Alright, now we're going to do one where we have a quadratic factor. So maybe something like the integral of minus 2x plus 4 divided by x squared plus 1, and then we have x minus 2 squared. Alright, so we got one linear factor that is repeated, and then one quadratic factor. So for the quadratic factor, we're going to need ax plus b divided by x squared plus 1, and then for the linear factor, we're going to need c divided by x minus 2 plus d divided by x minus 2 squared. Like this. And so then again, by writing the fraction on the left and the partial fractions and clearing fractions, we get minus 2x plus 4 on this side, and the other side we get ax plus b times let's see x minus 1 squared plus c times x minus 2 squared, or is it x minus 1? It is x minus 1, x minus 1, x minus 1, x minus 1. Alright, so x minus 1, and then c times let's see, the x minus 1 times x squared plus 1, and then plus e times x squared plus 1. Alright, when you span the right hand side, you get minus 2x plus 4, and I'm going to skip the details, but at the very end you get, when you expand the right hand side, you get a plus c times x cubed, a plus minus 2a plus b minus c plus d times x squared plus what is it, a minus 2b plus c, a minus 2b plus c, this is x, and then plus b minus c plus d. And when you match coefficient on the left hand side and the right hand side, you're going to get a system of equations. A plus c equals to 0 because there's no x cubed on the other side, minus 2a plus b minus c plus d is also going to be equals to 0 because there's no x squared on the other side. A minus 2d plus c will be equals to minus 2 because of that minus 2x, and then b minus c plus d equals to 4 because of the constant. Okay, solving these systems of equations using whatever you want, Gaussian elimination or whatever, or maybe just the graphing calculator, you get a equals 2, b equals 1, c equals minus 2, and d equals 1. So then the integral on the top then will be something like, so we're going to have 2x negative plus 4 divided by x squared plus 1 times x minus 1 squared dx is going to be equals to the integral of 2x plus 1 divided by x squared plus 1 minus 2 divided by x minus 1 plus 1 divided by x minus 1 squared dx. And then you just integrate this. This integral can become equals to 4 integrals. So one of them will be 2x divided by x squared plus 1 over x squared plus 1. Like this, minus 2 over x minus 1, and then plus 1 over x minus 1 squared, and then you integrate that. Okay, integrating each one of those, the first one requires integration by substitution, the other one is just inverse tangent, and then the other ones are just straightforward. So, you get the natural log on the first one of x squared plus 1 plus tangent inverse of x for the second one, minus the natural log of x minus 1 in absolute value, plus actually minus x minus 1 raised to the minus 1 plus c, and that's the answer. Okay, thank you very much.